Okay, so we spent Tuesday talking about normalization, the normal forms. Hopefully everybody got the assignment done. And so today we're going to talk about denormalization, which is the opposite of normalization. Basically, it is making an intentional decision to recombine some tables or to add calculated data to do something that you wouldn't normally do in a database for a very specific use case. So just like everything else in this class and everything else in computer science, there's always an exception. There's always a reason to do something differently. So the two most common ways that you go against normal form is if you use the same column in multiple tables, or, if you are creating either a new table or a new column of calculated data. So we talked on Tuesday a lot about why these are generally speaking bad ideas. But occasionally, you might be able to convince someone, or someone might be able to convince you that in your particular case, it makes sense to do this. So what are some of those? Some of those reasons might be? This is not a typical ER diagram for. I would call this a medium-sized database, right? It's not small, but it's certainly not the biggest. And trying to figure out where all your stuff is can be very, very complicated, right? If you're looking at this, or imagine this, 5 times as big, and you're trying to figure out your use cases for your business, if you have to go to the diagram every time, you're going to start getting a little frustrated. So joining these tables, right? Every time you run your query, in this case, think of it like Twitter, right? If you have a user table and a tweet table, right? By far, you are reading tweets much more than you are writing tweets, right? Because my personal tweet goes out to my millions of followers, right? But I cannot tweet millions of times a second. I mean, I'm a fast typer, but I'm not that fast, right? And so joining these tables millions of times a second so that all of you and your friends can read my fascinating tweets, right, is computationally expensive. So if you are doing something in the extreme where you're joining multiple tables millions of times a second, you might want to consider, do I want to put some of that data that is getting used the most back into a single table, right? The database can do some of this for you automatically in the back end. Database designers and programmers are pretty adept. And once you run your first query, they're actually pretty good at magically making things faster for you. They remember the queries you've done. So this has to be you have to be very careful with this one. If there's a need to maintain snapshots of history. So for example, what I talked about Tuesday with financial data. Often, if you record a transaction in finance, like between you and your bank, you write a check, you transfer money between two people, even if that transaction is a mistake, if the teller types in 1,000 instead of 100, because you needed to pay your roommate for dinner or something, right? They have to keep a record of that old transaction. Even though it was bad, by law, banks have to keep everything they do so that when they're audited and you know, the account balance on Monday was 100 and now it's 1,000, and there wasn't any transfer, they have to be able to explain why. Well, we had an error in bookkeeping. This is the original transaction. This is the other. But you don't want your database, when somebody says how much money I have, to show that old transaction. So you can have snapshots, which would mean you would have duplicated data by necessity. So if you need like a nightly snapshot, you might take a snapshot of your whole database and store that somewhere else. And another snapshot tonight, store that. Another snapshot tomorrow night. So you're duplicating your data, but the use case is you have to by law, right? So there's other individual cases where you might have to take snapshots of data. Historic reporting, same idea. But basically, as I talked about on Tuesday, WORM, worm, write once, read many applications, right? You don't want to have to go back, and if you are updating data a lot, then you don't want to have to maintain multiple copies that have to be updated a lot. The example I gave on Tuesday was when you take your 2019 profit and loss statement, yeah, maybe I have to go back once a year and say, oops, I mistyped something, we got to recalculate all that. But in general, right, we're going to write that profit and loss table once and read it over and over and over and over again. So that's kind of when you are okay denormalizing, is when you don't want to have it like a current grade in the student table, which gets updated all the time because it's very likely to be wrong. You could put in, once you've graduated, you could put in your final average grade in a graduated students table or something like that. That would be fine because it would never change again, right? Probably never change again. So another example that I like to use is census data. Here are some of the questions that they ask, right? What is your full name? What is your address? What is your phone number? How many people are living in this house? Wow, this slide is old. So these are some example questions that they ask you on the census, right? So here's a question for you. Once they take the census, which they're doing this year, again, oh, that's why that date is so old, because they do it every 10 years. Wow. All right. Are they going to go back and fix the census data? Right? If you write something wrong, if you mistype your phone number or miswrite it on the census, right? If I miswrote it on the 2010 census, am I going to call them up and be like, hey guys, I know you have like 300 million entries, but if you look me up, I actually mistyped my phone number. Like, they're going to be like, we care. Let me tell you how much we care. I'll call you back, right? I mean, they don't care, right? They're just going to write it all once, and they're interested in large trends in the data, right? So you don't need to have fully normalized tables, right? You don't need to have mortgage own rent with a separate table, one for owned with mortgage, two owned without mortgage, three, because this data is never going to change. They're never going to go back to 2010, add a fifth category, and then send out another census to everybody saying, if you think back to 2010, which category did you have, right? We missed a category. It's never going to happen, right? This is the perfect example of write once and read many, because they never rewrite the data. So you don't need to do things like splitting out this. It's not going to change the size of the database significantly to have, one versus a little bit of text. So you might as well just keep it in so that you don't have to join these two tables, right? On the other hand, you might want to split it out a little bit more because in census data, you probably are going to search by zip code, right? A lot of people, certainly thousands of researchers across the world, are going to look at the census data by zip code. That's something that's really common to do. Where are the richest neighborhoods in the United States? How does zip code correlate with mortgage, right? How does, first name correlate with education? I don't know, but that's the type of thing that researchers do, right? And so we need to split out address, state, and zip. Like that's the kind of normalization we would do. Because in our use case, that makes sense. You wouldn't just have, if you remember on Tuesday, we just had one big line with the address for like a food truck. You don't really care. You're never gonna like search all your food truck customers by zip code because they probably all have the same zip code. But in the census, it's really important, right? Denormalization, on the other hand, we're just going to put all of this data in this one table so that we don't have to do that join. When these millions and millions of people, of researchers, are looking at our census data, we don't want to have to join those tables every time. It'd be a lot faster to just put it in here. We know it's never going to change. Doesn't really change the size of the database very much. So let's just have it all in one table, one giant table. An example of same or similar column in multiple tables, right? You might have a customer info and a product info at Amazon, right? You're going to have two different tables, one for customer address, blah, 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 one for t-shirt size, color, blah, 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 blah. And every time they make a sale, you link a customer ID with a product ID. Well, say the sales guys at Amazon really want to boost their numbers. And so every day, all the salespeople are looking at the products that customers buy. If I have to join all these, and it's not just two, right? At Amazon, it would be like 20 different tables, right? You'd probably have a table for marketing, a table for Facebook leads, a table for this, a table for that, a table for, is it linked with advertising clicks on Google searches, something like that, right? So you'd have all these different tables that you could just say, boom, let's just duplicate that data. We don't actually care that much if it's 100% accurate up to the microsecond. We're just sales guys that kind of are looking at, we want to look for trends in our customers kind of thing. But we don't want to go all the way, right? This database over here is being updated. I don't know how much Amazon sells per second, but I'm sure it's a lot, right? We don't want to add more to this database. We just want to have one global database that shows us kind of what we need. It's kind of a stretch for an example, but I mean, you could make the case that the sales department could just have their own sales database. And what we'll do is every 5 minutes, 10 minutes, we'll just update it with their sales information that they want. So we're duplicating the data. That's not normalized, right? But you could argue that it makes sense in this use case. So I already have beat this horse to death, but the profit loss, if you're looking at historic data, which is what, every time you get a prospectus from any financial company, they're going from their historic data. Does not predict future returns, blah, 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 blah. But, it's almost all historic data, so you can calculate all that stuff and stick it in its own table, and that's fine. So you might not want to denormalize if it's a lot of space and a lot of time. So if you don't want to be churning, right? So in this example, right, you don't want to be trying to keep your sales info up to date in real time with the regular, like the actual sales data coming in, because you would just be churning. You're adding a tiny bit of convenience for a lot of work. So if you update this every 10 minutes or every half an hour or every hour, and because the sales guys really want to see it, that's fine. But it takes, it's going to take a lot of space. It's going to take a lot of processor time to do that. You got to weigh the benefits against the drawbacks. The reason I say, is this even a real issue anymore, is like, do you really think Amazon cares about how many servers they have? Right? They sell server space now. Like, you can have free servers on Amazon. If you guys want to set up your own web server, you can get a free virtual server on Amazon now. AWS, Amazon Web Servers. So like, I don't know, maybe 20 years ago, people really cared about space and processor time. Now it's like, it's just such a commodity. It's so cheap, nobody really cares. Yeah, you could have incongruities, right? So again, kind of using this example, if I just update my sales team every hour, no, they're not going to have the last hours of data. Does that really matter for my sales team? Probably not. They're not going to suddenly have a flash of brilliance. They're looking at, who's bought the most hammers over the last month. I should probably give them a call and try to sell them more hammers or sell them some nails, right? Like, that's what salespeople do, right? They look at trends and data and they try to figure out how to help that customer spend more money, essentially. So they don't really care that much. Same argument for stuff like Twitter, right? If you have a Twitter app on your phone, do you really care if it's like 100% up to date to the microsecond with whoever you're following? Or can you wait 5 minutes to receive their tweets? Right? Does it really matter that much? Not to me. Extra programming, this is the maintenance argument. So going back to this again, right? Somebody's got to maintain that table over there, the sales table. You're going to have some poor programmer who has to deal with salespeople. Oh, wait, you know what? We don't just want this. We want, one more table. Could you just add one more table? Could you just add one more field? Could you make it in blue? Because we like blue databases. So anytime you start customizing your data for somebody or for a business, I say there's a high likelihood of cheesy hacks because there's always one more thing that they're going to ask. And the thing that I mentioned on Tuesday, the reason that people have used MySQL Server for so long and it's so popular is because of the idea that if you do it right, the data makes sense the way it is. And you want to avoid cheesy hacks, extra programming, stuff like that. Make the data make sense in your ER diagram so when you look at it, you know how it works. Extra documentation, right? If I create this special table for the sales team, somebody has to make sure that all the other programmers and database people in the company know why it's there, how it works, who gets to use it, all this kind of stuff. So again, more people power, more effort, more brain work. It's kind of a pain. Having a clean ER diagram is really nice. Right? So if you let me put it this way. If you are never do something just to be nice. Right? If the sales team is like, oh, hey, I hear you're the database guy. Could you just add this little table for us just so that we can see our own data? Right? That's easy for you. You're the database guy. It's not easy for you in the long run. Future you will hate past you if you do that. Right? Future you likes a clean ER diagram that makes sense with the business, right? The more little things, more denormalization you add, the more duplicated data, the more calculated data, the more cheesy hacks, the more documentation, the more frustration. So you have to make sure that there is a real business need for it. So you only want to use it if you actually need it. So the other question I sometimes get for those who have used database, how many people have ever heard of views? A couple of people? Okay, so views are virtual tables. And this can be a solution to that problem of I kind of want to create a table for these people, but I don't really want to do all that stuff I was just talking about. So what it does, especially if you have a very complex query that you use a lot, what it does is it creates what people call a virtual table. So say you have a database with, oh, I forgot my thing again. All right. Say you have a database with like 50 tables in it, right? And you need to join 10 of them to get exactly the data you want. And you use that query quite a bit. It's kind of a pain to keep that query saved in like a text file somewhere that you can just pull out when you need it. What you can do is you can call that query and save it as what's called a view. And in the background, the database slurps all that data together and stores it in memory for you. So accessing that view is really, really fast. You're basically telling the database, I'm going to do this query a lot. So you should optimize it as much as you can and put all that data in memory as much as you can. So if you have a very complex query that you use a lot, it makes a lot of sense, especially if it matches a business case, right? Like for some reason, like we're a lumber company, and in order to ship a house, we have to look at the lumber orders, the nail orders. We have to figure out how much we have in inventory. We have to figure out from accounting whether this person ever pays, blah, blah, blah. We got to hit all these tables to make one big report for this is how much one prefab house is going to cost this customer, right? So my big complex query, I store it as a view, and it's really easy for me to say, select star from my cell one prefab table, virtual table. Some advantages to this is security. Say your sales guys want to be able to sell a prefab house, but you don't want your sales guys to see people's social security number, which you might have. Or, I don't know, that's not a great example. But patient data. You're at Mayo Clinic. You don't want the, I don't know, somebody who's looking at a patient's data to be able to see their social security number and all this other stuff that they have no reason to see. You can create a view that only selects like their name and their clinic number out of their personal info table and puts it in a view. You don't give anyone access to that full patient data table. You only give people access to the view of the patient. So like when you check in at the desk at Mayo, they shouldn't be able to see your social security number. There's no reason for them to do that. So they might have a view on their screen of your name, your clinic number, your birthday, and some other stuff. So with a view, you can just select things out of various tables, give the proper people access to just that information and not everything in your database. So it's a nice way to manage security. Again, simplicity. You can see exactly what you want in one table without having to do complex queries. Select star from patient view will give me exactly what I want every time somebody checks in. I don't have to do all this I don't have to sift through a bunch of data. Consistency, right? So if I can have computed columns inside my view because it's just a select statement, right? My view might be select sum from dollars sold or something like that, and every time somebody looks at that screen, it automatically updates. It's not really a computed column in a table because it's calling that select statement every single time I look at that view. Right? This complex query, it's calling it every time I look at it. So if I want to see computed fields, a view is a good way to do it because it'll do it every time I look at it. Partitioning, say I don't want to look at the entire database the whole time. If I have 500 tables and I only really look at 3 of them, I can make a view of just those 3 tables. Makes it really nice. Doesn't take any extra space, right? All it is on disk. Again, space is not a big deal these days as it used to be, but doesn't take anything. This is actually where I've seen it the most is our branch in Des Moines is still using IBM OS/2 on their, computers, and nobody knows how to program those anymore. So when they do a database query, it has to be this query. We cannot change that program anymore. Or it's like some Fortran program, right? We don't know how to program in Fortran, or the business doesn't believe it is worth our time to hire someone to reprogram all this, right? So what we'll do is we'll create a view that matches what that old program needs. Our database is way different than it was 50 years ago, but we can still create this virtual table that old program thinks that it's seeing. So this is kind of where I've seen it the most is, yeah, we've migrated 10 times to new databases since that old program was written, but as far as that old program is concerned, this database table still looks the same because I created a view. Disadvantage is this query is always run, right? So like I said, if you want to have computed columns or anything like that, it's great because it's run in real time. The downside is that the query is always run. So if you have a lot of people accessing this, then you kind of run into that problem that I was talking about before with denormalization, where if you're doing it a million times a second, you probably just want to put it in a real table, not in this virtual table that has to run the query every time. And then the underlying data may change, right? This is a business risk again. So say I have this view that hits 50 different tables, and then some database guy comes in and says, oh, you know what? We don't really need the size of the customer's swimming pool in their backyard anymore. Let's just delete that. All of a sudden, your view doesn't work anymore, and you don't know why. So they don't solve the same problem as denormalization. They are good for these things, but they do not solve, they're different, they solve different problems than denormalization. Denormalization is kind of what we're concerned about because we are, in this class, moving towards bigger and bigger data, right? We're going to be talking about things like how Facebook works. Views would not work with something like Twitter or Facebook. If you have a really complex query that you're trying to speed up, putting it in a view won't help you. I mean, it'll help you a tiny little bit because the database can optimize it, but you're still joining all those tables every single time you call it. Right? A view, the point of a view is simplicity, security, and some kind of business logic that says, I look at this, I want to be able to pretend that this is a table that I look at. It does not help you with what denormalization helps you with. So there's a really good article on when you should denormalize, and that is basically it for today. So the bottom line, as usual, is it depends.